If it's average velocity times time, that's my displacement. So that is just equal to my displacement, which we'll use delta of x. So we actually have another one of these equations, one of the cake formulas. We have delta x, s, r, whatever letter you're using, is equal to v I t plus 1/2 a t squared. Again, acceleration is constant. Dropping back just a little bit. I got close to deriving this formula and I went for it, but let's get back to the average velocity question. I had the average velocity times time is equal to VIT plus VF minus VI 1/2 times time. That's what we had on the other page. I put the 1/2 in a slightly different spot, but commutative property of multiplication rules.
How did we get the like v times t over there?
You looking here or up?
Like v times t, the one we circled.
How did I get that? Oh, because we established over here that the area of the yellow section and the red section are the same. This is the area of the trapezoid, that's the area of the rectangle. So on the next slide, screen, I've made a substitution for VF. That's what this is, that's my VF right there. And then, so that's the area of the trapezoid, and then down here, I set the area, that reduces to this, that's also equal to the area of the rectangle.
So the area of the rectangle and the trapezoid are the same?
Yes. Because that's how average is defined.
Okay.
More sophisticated than just adding up all the numbers and dividing by however many you have. So this would be VIT plus VIT plus 1/2 VFT minus 1/2 VIT. Well, I got VIT and a half VIT, so I can combine those, so I get 1/2 VIT plus 1/2 VFT. That should be a T there, not squared. Which is V average T. If I divide through by time, time drops out, and I'm left with 1/2 VI, my average, is equal to 1/2 VI plus 1/2 VF, which is just VI plus VF divided by 2. It's just the average of the first and the last one, if acceleration is constant. Which is basically what several people did. So my average velocity whichever form you like, is equal to 5 plus negative 10 divided by 2. What is my displacement? In other words, where do I end up relative to where I started? Two different ways of going about it.
With 5 meters way out.
Sorry, what'd you do?
Where's the starting point?
For where are we, at the end, after 4 seconds, where are we with respect to the starting point?
Yeah, but where is the starting point?
It doesn't matter. If I were telling you, if I was asking for the position, then it would matter,
Yeah.
but
-10 meters per second.
too far.
Meters.
Yeah, there we go, -10 meters, how'd you get -10 meters?
Because it says that the object goes from 5 to -10, so that would, it would start at 5 and then go back to -10.
That's the velocity.
Oh, but you said.
That's just where it ends?
I wanna know the displacement.
Ah.
Where is it with respect to where it started? I will say the answer is -10 meters. It sounds like you got there a strange way.
Yeah.
Brilliance or lucky, I don't know. Kritika,
I applied the formula.
this one?
Yeah.
So if you plug that formula in, you get 5 times 4 plus 1/2 times -3.75 times 4 squared. And you got, I assume, -10 meters. How else could you have done it?
The average velocity times time.
Yeah, because you could have done -2.5 times 4. That gets you to the same place. So what we're saying here is that I can find displacement using this formula right here, if acceleration is constant. Or I could just multiply the average times time. And since, I was about to erase this, any questions on this before I erase?
Even better.
I'm sorry. So this is also equal to the average velocity times time, which I can therefore write it as delta x is equal to VI plus VF over 2 times time. The third of the gate formulas. We've got one more.
Are all of the equations that we've been talking about, are they all displacement functions? I mean, displacement equations?
That's not.
Okay.
And the last one. You'll find with these equations, given initial velocity, final velocity, acceleration, time, displacement. So basically 5 basic quantities. Each equation will have 4 of the 5. 2 of the equations start out with delta x. 2 of the equations, this one starts out with VF, the other is VF squared. But we need to get there. Notice also, we could have found average velocity one other way, and I don't recommend it, but I'm gonna do it anyway because if your mind blanks at a bad moment, we started out at 5 meters per second. So this is my velocity in meters per second. And time in seconds at 0. Every second, my acceleration, or throughout the whole thing, my acceleration is -3.75 meters per second squared, which means it changes -3.75 meters per second every second. So after 1 second, I'm now 1.25 meters per second. The difference is -3.75. After another second, I'm at -2.5 meters per second. After 3 seconds, negative. Did I miscount there? So that's 3.75, 3.75, 7.25, no, 6.25. And at 4 seconds, -10. So alternatively, finding an average, I could have added up those 5 numbers and divided by 5, and presumably I'm gonna get -10. The other way that I approach deriving that the average velocity is just the sum of the first and the last, again, acceleration is constant. There's nothing particularly special about every second. I could do every 2 seconds, in which case I could have averaged those 3 numbers and divided by 3. Alternatively, oh, not -10, -2.5. Alternatively, nothing special about every 2 seconds. I could just go every 4 seconds, in which case I just add those 2 and divide by 2. Okay. Questions before we talk about dot products? There are 2 ways of multiplying vectors. One is a dot product, the other is a cross product. Cross products we will deal with near the end of the semester. Dot products we will deal much more heavily when we get to chapter 7. But I do need to introduce it just to justify what I'm about to do. If I have a vector like this and a vector like that, we will cleverly call that one A and B. I can break A up, or B, I can break one of them up into its components, so let's go ahead and do that. So A, I've got a certain amount that I go to the right, a certain amount that I go up. So my vector A is a combination of this plus that. What do I call this? A sub I and A sub J. And what the heck, let's go ahead and define I to be in the direction of B and J perpendicular. So I have this vector, A, which is this component, I hat, plus that component, J hat. Erase. There we go. That is definitely sloppy. Let's see if I can do slightly better. A sub J, J. If I'm going to multiply them, if I'm multiplying with a dot product, the way that I would write that is A dot B. Thus, dot product. Dot products are also called scalar products because the answer is a scalar. So what I'm going to do is when I'm multiplying these, I am going to multiply the parts that are parallel to each other. This part right here is not parallel to B. So what I end up doing is A sub I hat, plus A sub J hat, dot B, which is a magnitude of B in the I hat direction. And then I multiply like components. I multiply those components, and I multiply, well, there's an implied plus 0 J hat. I multiply the J hat components, and I'm left with AIB. So whatever this component is times whatever the magnitude of B is.
Is that first letter, is that an I or a J? Like,
Here,
yeah.
that's an I. I curl my I's to the right and my J's to the left. Or, sorry.
Thank you. So, on the picture that you drew, it says A J hat, but the one below it says just A I. So when I'm looking at the formula,
Yeah, my notation got horrible there.
sorry, I just want to make sure I'm.
All right, so it's B, and then properly done. AI is the length along there, and AJ is the length along there.
Oh, okay.
Yes,
Is that just 0 or is it
that's a 0.
0 vector or just 0? Is it 0 vector or is it just 0?
It's a 0 vector. I wanted to emphasize the fact that there is an implied J hat here with a magnitude of 0. So that's why I wrote it as 0 J hat as opposed to 0 with the vector symbol over the 0.
explain the bottom equation again? How did you get the aij hat plus aj j hat? Like, how did you get?
I get that. I broke A up into perpendicular components. If I gave you that angle and I gave you the magnitude of A, you should be able to do that using right triangle tree. For some of you, it'll be natural. For some of you, you need to work on it, but that's how you would do it, using tree. So the length of this component here, I just labeled as AI. The length of that component, I just labeled as A. That's supposed to be a J there. I can see how my I's and J's might look very confusing. In my mind. I feel like there's more to your question. Oh, so since I define I hat, J hat like this, then to get from here to here, I can either go straight at that angle, which is polar form, or in rectangular form, I go to the right, or the I hat direction, this amount, and I go in that direction, AJ. So I wrote it in rectangular form. It did not look like convincing that you were convinced.
So like, are we looking for the vector of the A vector? Are we looking for that one, or?
We're looking for the part of the A vector that is in the same direction as B. Because when you do dot products, you multiply like components.
But AJ is not in the same direction as B. Like the J component is not in the same direction.
Right. And so when we multiply that like component, this AJ here with that J hat there, we get 0.
So just so I'm understanding, basically what we're doing is we're taking like the distance from,
The vertex.
yep, for the I and the J, and what we're doing is we're getting essentially, I think I understand what you're doing. So like the reason why it's 0J hat, for example, is because B doesn't go in that direction at all.
Right.
And then AJ is the annotation for the upward.
Yes,
Okay, I get
Yes.
it, okay.
exactly.
Wait, that confused me because can you just say like what we're solving for in this? Like, can you just point to it? Like what?
That ultimately was what we were shooting for.
Just AI times B?
Yes. That a dot product, when you do a dot product, you are multiplying the part of one vector that's in the direction of the other vector times the other vector. Magnitudes. All right. I feel like let me do another example in just a moment, Riley.
I just wanted clarification. So it's 0J hat. Is it because the B vector doesn't have any J direction, or is it because you're solving for
No,
the I hat?
it's because there is no component in the J direction.
Oh, okay.
I defined the I hat to be in the direction of B.
Oh, okay. All right.
If I define I hat to be at somewhere in between A and B, they both have components.
So like theoretically, if you had a number, instead of like A this direction, B this direction, it would be like A is over this amount and then up this amount, this number and this number, and then B is over this amount, but it doesn't go up this amount, so it's
Right.
just 0. So if we could look at it in terms of like numbers.
Yeah, all right, let's do numbers then. I'm going to define B as 10 meters I hat, and sure, I hat that way, J hat that way. I'm going to define A as being, there's a different number there, 5 meters and 37 degrees. Let me just sketch out A. So 37 degrees is going to put it somewhere around there. That's my 37-degree angle. My hypotenuse is 5 meters, and I'm breaking that up into its components. I have a right triangle here. I'm breaking it up into perpendicular components. Because if it's not perpendicular components, then you're asking for a whole lot of math. The adjacent side here is going to be the hypotenuse. times the cosine of 37 degrees. And my opposite side here is gonna be 5 meters times the sine of 37 degrees. I picked 37 for a reason. This is roughly equal to 3, and that's roughly equal to 4. So my A vector in rectangular form, it's 4 meters I hat plus 3 meters j hat. So my dot product, if I'm doing A dot B, that is going to be 4 meters I hat plus 3 meters j hat dot 10 meters I hat. I multiply like components, I multiply the I hats together, so I get 40 meters squared plus 0. So 40 square meters.
So you multiplied the 4 I hats and the 10 I hats.
Yep.
And then the 3 meter j hat, because there's no parallel to the A, then it means 0.
Yes.
Okay, cool.
What if the B value has like 2 digits for its vector? Do you have to FOIL it then,
Right.
or?
So, oh, guess I didn't need to erase that part, but I did. So if I do a dot product of 3 newtons I hat plus 4 newtons j hat dot -2 meters I hat plus 5 meters j hat. So I multiply these two vectors. You multiply it like components. I multiply the I hats together. I get -6 newton meters. I multiply the j hats together. I get plus 20 newton meters.